Hello everyone, in this video we are going to discuss with the question find peak element. So in this question we are given some numbers in the array nums and we need to determine the index of the peak element. And if we look to the definition of the peak element, it says that the peak element is strictly greater than its neighbors. So for example, if we have an array something like this 1, 2, 1, 3, then we can definitely say that 2 is the peak element, since it is also greater than its left neighbor and also greater than its right neighbor. So we need to determine the index. So in this case the answer will be 1. Now let's look at the approach. In this question we are also told that the starting element is greater than its left neighbor, that is the left neighbor of starting element is -1, and we are also told that the ending element is greater than its right neighbor, because the right neighbor is given as -infinity. Okay, so yeah, let's look at this ones. Let's suppose we know that our peak element will always lie between this starting index and ending index. We can say that, right? Our peak element always lie between that. So if we initialize our starting index with 0 and ending index with n-1, n being the size of the array, then yeah, our first job is done, that is initialization of starting index and ending index. Okay, so now we need to come to the logic, like what we are going to apply. Let's suppose for any element which is a peak element, let's suppose this is a peak element. So can we say that this element will be greater than its element at the right? Like if this is the peak element and this is the element to its right, then we can say that this element is definitely greater than this element. Okay, so what logic we are going to apply is, let's suppose our answer lies between starting index to ending index, and let's suppose we encounter a mid, and let's suppose this mid value is greater than the value of mid plus 1. So what we can say is that our final answer will lie, like a possibility of final answer is between starting index and mid. How we can say that? See, this mid value is greater than mid plus 1, right? So like let's suppose the mid value is, for an example, let's suppose take mid value as 4 and this mid plus 1 value is 3. Now what are the possibilities? The possibilities are this 4 goes to the left, like it keeps on going to the left and keeps on increasing, like this is 4, this is 5, this is 6, this is 7. If this is the case, then we will definitely get our answer as this seventh number, the index corresponding to this 7, because to the 7 the number is -1, like the number is less than 7. So this 7 will be the peak element. Similarly, if let's suppose it does not gets on increasing and at some point of time it gets decreased, let's suppose this value is 4, this value is 5, but this value is less than 5, that is 4, and from here let's suppose it happens something between this. This is the case. So can we say that this 5 is the peak element? Isn't it? This 5 is the peak element, right? And let's suppose the third case, that from here, that is from the mid, the element keeps on decreasing, like 3, 2, 1. If this is the case, then definitely this 4 is the peak element. So what we can say is, if nums of mid is greater than nums of mid plus 1, then our answer will definitely lie, like we will get one of the answer between SI and mid. So what we can do is, we can shift our starting ending index to mid, and we can say yeah, mid is one of the possibilities, so we can store it in our answer. Else if this is not the case, like mid plus 1 is not greater than mid, so yeah, exactly opposite will happen. Like in this case there was a possible answer to the left, so in the other case there is a possible answer to the right, but mid can't be the answer, since the mid value is not greater than mid plus 1, so mid can't be the answer. So in this case we will not substitute our answer. What we will simply do is, we will just shift our starting index to mid plus 1 and say that yes, there is a possible answer from ending index to, like from this mid plus 1 to ending index. A possible answer lies in this range. there can be multiple peak indexes, but we need to return only a single one, like any one we can return. So yeah, we can approach like this to get to our answer. Let's code it down. Let's take n as the size of the array. Okay, so let's initialize our starting index with 0 and ending index with n minus 1. Let's keep an answer and let's write the entire template which we discussed earlier. Like, I am not making any changes over there. I am copying the entire template. Starting index less than equals to ending index, and mid is starting index plus ending index minus starting index by 2. Now there is a condition which it is true is one case, if it is not true it is other. In this case we are doing starting index as mid plus 1, and in this case what we are doing answer as mid and ending index as mid minus 1. And the only condition which we are going to apply is like if nums of mid is greater than nums of mid plus 1. Okay, so this is what we discussed in previous lectures. So now the only thing remains is like we are comparing mid with mid plus 1. What if the mid is the last element of the array? What if, like, let's suppose mid is like you have an array like 1, 2, 3, 4 and you get mid as this. Just tell me when you will get mid as the last element of the array. If mid is the last element of the array, can we say that yeah, starting index is also the last element and ending index is also the last element, isn't it? If this is the case, then we always know that our answer lies between starting index and ending index. And so if this is the case, can we say that this is our answer? Because there is only a single element between starting and ending index. So can we say that this is our answer? So for that, what we can do is, we can see that yes, if our mid is equal to the end element, that is the index mid is equals n minus 1, then we can simply return mid from that. And from here we can return our answer. So this is the template which we discussed. I hope you all have watched it. So yeah, let's submit it. It's running. Let's submit it. Okay, so it's working. Hope you all got it. Thank you.